everybody. In this video, I'm going to go over section 1.3. We're going to look at limits graphically. I'm going to define limits first, and then we'll do some examples, okay? So in one of my previous videos, we saw that even though the function x squared minus 4 over x plus 2 is not defined at x equals negative 2, as the value of x gets really close to negative 2, the function has a value. It approaches negative 4, okay? And this is actually the idea of the limit of a function, okay? So let me just show you something real quick. So as I said in my previous video, you guys know that since f of x equal to x squared minus 4 over x plus 2, it's actually the same as we have x plus 2 times x minus 2 all over x plus 2. You can cancel x plus 2 and you get x minus 2. Then we can say that x squared minus 4 over x plus 2, it's exactly equal to x minus 2 for x not equal to negative 2, right? Because negative 2 is not in the domain of the function. Therefore, as you learned in second grade, the graph of x squared minus 4 over x plus 2, the graph of this function, is just the graph of x minus 2 with a hole at x equals negative 2. So the graph of the function will look like, so when x is equal to 0, I get that y is equal to negative 2. So when x is equal to 0, I get that y is equal to negative 2. So I have a point here. Let me change colors. So I get a point here. And then when y is equal to 0, then x is equal to 2. Okay, so it goes through this point also. So perfect. So then the graph of x minus 2, is just this graph, okay? Something that looks like that, going through those 2 points. Now, this is the graph of x, so I'm just going to draw the whole line. So this is the graph of, this is y equals x minus 2. Now, the graph of x squared minus 4 over x plus 2, once again, is just the graph of x minus 2 with a hole at x equals negative 2. So then if I want to take this graph and turn it into the graph that I'm looking for, then I'm going to say, so x squared minus 4 plus 2. And then here at negative 2, I find my function, and then it'll have a hole right here. Now the question is, what is the y value there? So the y value will be the value that the function approaches as x approaches negative 2. So as x approaches negative 2 from either side, it could be the right or the left, right? As x approaches negative 2, the value of the function according to our table approaches negative 4. Therefore, that's how we know that this value here is just negative 4. Which is the same as just substituting, like plug in negative 2 into x minus 2. If you do negative 2 minus 2, you get negative 4. Okay? So then that is the actual idea of the limit. Like even if the function is not defined at a value, if the function approaches a number, then that's my limit. Okay, so let me define this. So definition. The limit as x approaches a of f of x is L if as the value of x, so as x gets closer and closer and closer, so I'm going to say gets close to a, the value of f of x gets close to L. Okay, that's it. And then again, what does it mean for a function to get close to a value? It means what we saw in the previous example, okay, with the little table. So I'm going to say again, gets close. Okay. And then what's my notation? So for notation, we have notation. Check this out. Lim for limit as x approaches a, so as x gets really close to a, of my function f of x is equal to L. So what you have to keep in mind, is that this is the value, so A is the value that the x, it's something happening on the x-axis. So this is happening on the x-axis, and then L is something happening on the y-axis, okay? So if we go back to our example, so in our example, then we know that the limit as x goes to, well, x was approaching here -2, right? So it'll be as x approaches -2 of our function, which is x squared minus 4 over x plus 2. So of x squared minus 4 over x plus 2, it's equal to the value that the function was approaching on the y-axis, which in this case is -4, okay? Perfect. So -4. Okay. So now let's do some examples, okay? So hopefully looking at this example with the table helped you understand how we can find limits graphically. So if I define the function graphically, like in this case, and I'm looking for the value, I'm looking for the number that the function approaches as x approaches -2, then as x approaches -2, I get closer to -4, right? It doesn't really matter if I'm coming from the left or the right, I'm going to approach -4, okay? So let's use that information to find limits, graphically speaking, okay? So you have to keep in mind that the limit is something local, okay? So for example, if you want to find the limit as x goes to -2, right? Like here, limit as x goes to -2, we have to look at what's happening to the function as x gets really close to -2. It is something super local, super local, okay? So let's see. I'm looking for the limit as x goes to -2. So say, for example, if you're here really close to -2, you get that value, okay? You get that value. The closer I get to -2, the closer I get to -2, the closer I'm going to get to whatever this value is, okay? So let's see. Do you agree with me that this is 2.5, okay? That's like 2.5, so I'm going to put it here, 2.5. Okay, same thing happens when I'm like really close to -2, but I take numbers that are larger than -2. So say here, see, it's taking me to the same y value, okay? The way I actually see this is I get on that graph, and it takes me there, right? And then if I get on the graph from the right-hand side, it also takes me there, then that's the limit. Meaning the limit as x goes to -2, it's equal to 2.5, okay? Now, as we saw, this is exactly what we saw when we were doing x squared minus 4 divided by x plus 2, okay? The function was not defined at -2, but the limit, you could find the limit, okay? And it was -4. In this case, the limit is equal to 2.5, but if I try to find the value of the function, I get an open circle, right? I get an open circle, and whenever we get open circles, we know that the function is not defined there. Therefore, the function, so f of -2, the function evaluated at -2, we say it's undefined. Okay? Perfect. Now, let's find the limit as x goes to 0, okay? Let's find the limit as x goes to 0. So we know that 0 is right here, right? And then again, if I'm looking for the limit as x goes to 0, it's something super local, So I'm looking at what happens to the function as the x value approaches 0. And then again, I get on that graph, and it takes me to that value. Same thing happens if I come from the right. It takes me to the same value, which it happens to be 3. Therefore, the limit as x goes to 0, it's equal to 3, okay? Now, this is a very interesting case because in this case, if I have that, the function is defined there, then no problem, okay? So if the function is defined there, then that's my limit, okay? No problem. No problem, okay? Let me see if I can write 3 here. Right? No problem. So that tells me that then in this case in particular, the limit as x goes to 0 is equal to 3, and the value of the function, it's also equal to 3. No problem. No problem. Okay? I'm going to skip the limit as x goes to 1 for a second. Let me do the other two. Now, what's the limit as x goes to 3? Again, I have two very local. So if I'm looking for the limit as x goes to 3, I focus here as x goes to 3. And then I know that whenever we cross the x-axis, we know that y is equal to 0. So then here we go. Just like we did before in this case, the limit is equal to 0 and so is the value of the function. No problem there, okay? And now we have the limit as x goes to 4 of my function. So then again, let's see what happens as x gets closer to 4. Think about it for a second. Think about it for a second. I get on the graph, okay? So if I'm getting really close to 4, I'm getting on the graph, okay? And the closer I get to 4, the closer I'm going to get to this value, okay? So you get on the graph, you get on the graph, you get on the graph of f of x, you get on that graph, and it takes you, whether you're taking smaller numbers or larger numbers, as you get close to 4, it takes you to this value, which is 2. So the limit as x goes to 4, it's equal to 2, because that is the number that the graph of the function approaches. However, I have an open circle, so I know that the function is not defined there. But I can do whatever I want. It's my function, so I decided to define it here, right? I decided to draw a closed circle here. So this is the value of the function. Therefore, the value of the function is actually just 1, okay? So f of 4, it's equal to 1, okay? And now we go back and we look at the limit of x as x goes to 1 of f of x, okay? Actually, finding the value of the function at 1 is easy, right? Because we know that the closed circle gets the value. So let's just do that. So say, for example, what color do I want? Let's use pink. Okay, so I know that f of 1 is equal to, well, the closed circle, whatever. That is, I'm going to say 3. Fine. So that is equal to 3. But what is the limit as x goes to 1 of f of x? What is the limit? See how I keep saying the limit? What is the limit? The limit as x goes to 1 of f of x. So that's hard to tell, right? Because if I'm coming from the left, if I get on my graph and I come from the left, it takes me to 3. But if I come from the right, it takes me to -1, okay? So if I'm asking for the limit, then why am I getting two different limits, okay? So that tells me that I have to go back. And here, when we're defining the limit of a function, we have to make a little note, okay? We have to make a little note, and we have to add here that if the limit exists, so if the singular limit exists, then it is unique. Okay? If the limit exists, then it is unique. Big deal, okay? So now I'm going to take a little break from this so that I can give you a new definition, okay? Check this out. So now I want to talk about one-sided limits, okay? One-sided limits. So by one-sided limits, I mean literally like I'm taking the limit either from the left or the right. So imagine that we have a here. We have a here, okay? So if I take the limit from the left, I am approaching a from the left. I'm taking numbers really close, like really close to a, but smaller than a, right? So I'm gonna say, but x is less than a, okay? Since I'm coming from the left, I know that my x values are less than a, okay? So if I did x minus a, I'm gonna get something less than 0, okay? So I'm gonna get something negative. That's why the notation is limit from the left. I'm gonna write lim as x goes to a from the left. And that's why I get that negative there. So f of x, okay? Right? Does that make sense? Hopefully it does. Okay. Now, if I'm coming from the right, then here from the right, if I'm coming from the right, then again, we're taking numbers really close to a, but they're larger than a, okay? So this is x greater than a, and then again, if I do x minus a, I'm getting something greater than 0, and that's why my notation tells me that now I'm going to write lim as x goes to a from the right of f of x dx, okay? Now, the most important thing here now is that if the limit exists, it's unique. Meaning, if I take the one-sided limits, meaning if I take the limit from the left and the right, I have to get the same thing, okay? So let me write it down, okay? Let me see. So, if I have lim as x goes to a like that, like I don't have the negative or the positive, then that means that I have to find both one-sided limits and they have to be the same. So if I say limit as x go to a of f of x, it's equal to L, that's the case if and only if the limit as x goes to a from the right is equal to the limit as x goes to a from the left, and it's equal to L. So one more time, in order for the limit to exist, it has to be the same from the left and the right, okay? And I have one more piece of information for you, okay? We are going to allow one-sided limits to be plus or minus infinity, okay? We will allow one-sided limits to be plus or minus infinity. So now that we know the definition of one-sided limits, we can go back to our problem and find the limit as x goes to 1 of f of x. Now, I know that if the limit as x approaches a number exists, then it has to be the same thing from the left and the right. Now in this case, the limit as x approaches 1 from the left, I'm approaching 1 from the left, okay? This is me approaching 1 from the left. This is x approaching 1 from the left. So I have to get on the graph that comes from the left, right? And it takes me to, I'm going to say this is 2.5, and it takes me to 2.5, okay? Therefore, the limit, when I get on that graph, it takes me to that value, which we're saying it's 2.5. When I approach 1 from the right, so this is now me approaching 1 from the right, I have to get on the graph that comes from the right. I mean, we'll know that this is something local, so I'm actually just getting like really close to 1 from the right. I get on that graph and it takes me to -1. So the limit as x goes to 1 from the right, it's equal to -1, okay? Therefore, the limit as x goes to 1, since I got two different values, the limit as x approaches 1 does not exist. I'm going to say D and E does not exist, okay? And then why? This is the reason why. This is the reason why. So because I'm going to say limit as x approaches 1 from the right is not equal to the limit as x approaches 1 from the left, okay? Perfect. You can look at the definitions again, and now we do another example, okay? Beautiful graph again, and now given this graph, I have to find all those limits, okay? So let's just jump right into it. Okay, so the limit as x approaches -1 from the right. So this is -1. I'm approaching -1 from the right. Then I get on the graph. Coming from the right, and it takes me to infinity. Okay, one-sided limits can be infinity or negative infinity, no problem. Okay. Now, when I come from the left, I get on the graph that it's approaching, that it's coming to -1 from the left. So I'm getting on this graph now. I'm getting on this graph, and it takes me to -infinity. So since the limit as x goes to -1 from the left and the right, or not, we don't get the same values, then we say that the limit does not exist. And in this case in particular, there are no closed circles anywhere here for -1, so we say that g of -1 is undefined, okay? Perfect. So now we'll look at the limit as x approaches 0 from the right. So from the right, again, I'm approaching 0 from the right. So I get on the graph, I get on the graph, I get on the graph, and it takes me to 3. If I'm approaching 0 from the left, I get on the graph, I get on the graph, I get on the graph, and it takes me to 1. Is 1 equal to 3? Is 1 equal to 3? No, it's not, right? Since 1 is not equal to 3, they're not the same, therefore we say that that limit does not exist. But g of 0 is the value that the function has, is the closed one, okay? So we know that then that is g of 0, we get 3. Okay? Let's do 1 now. Let's do 1 now. So now we'll do 1. So let's see. Okay. So now we are approaching, what is it? 1. Here we go, 1. So the limit as x goes to 1 from the left, I get on the graph, I get on the graph. From the left, it takes me there. Actually, from the right takes me to the same value. So I know that the limit as x goes to 1 from the right and the left is equal to the number 2. Since from the left and the right we got the same value, then we say that the limit as x goes to 1. Don't forget this, okay? If it doesn't say anything, then that implies that I have to look at the one-sided limits and compare them. If I get the same thing, then that's the limit, okay? Perfect. So then this is equal to 2. Now, g of 1, there's an open circle there, it's not defined. It's undefined, okay? Perfect. So let me just review this real quick, okay? So for example, in this case in particular, this example gives you all the possibilities you can have, all you can have, okay? So for example, here in this case, we have that the limit exists, but the function is not defined, right? Here we have that the function is defined, but the limit does not exist. Here we have that the function is defined, the limit exists, but they're not the same thing. And then here we have that the limit exists, the function is defined, and they are the same thing. That's it. That's all you can have, okay? Okay. So, again, and I mean, yeah, I always say this, but you know how math works, okay? So in math, we like to, undo what we just learned how to do, okay? So I gave you the graph of a function and I asked you to find limits from the graph of a function, okay? So now I'm doing the opposite. Now I'm giving you conditions, now I'm giving you the limits, and I want you to sketch the graph of a function satisfying those conditions. Again, I'm not gonna lie to you, I'm the one writing the exam. I love graphs, okay? So let's see. So first one we have, the limit as x goes to 2 from the right is equal to -infinity. Well, that tells me that here if I have 2, here, the fact that the limit as x approaches 2 from the right, the fact that you get -infinity tells you that that is a vertical asymptote. You know this definition. So I try to get really close to 2 from the right, and it takes me to -infinity. I'm done. Perfect. And now I move to the next one. The limit as x approaches 0 from the right is -1. So if I'm approaching 0 from the right and it takes me to -1, then, I don't know, here I have -1. There you go. From the right, it takes me there. And do something like that so that you know you're coming from the right. Okay, what else do I have? Oh, I'm reading this the wrong way. I guess I'm supposed to be reading it like vertically, whatever. Wait, this is horizontally. Like that. Okay. Okay, here we go. The limit as x goes to 2 from the left is infinity. So if I'm coming from the left, it has to take me to infinity. So I'm done with that condition. But f of 2 is equal to 1. F of 2 is equal to 1. So there you go. There you go. Okay. What else? The limit as x goes to 1 from the left is equal to 2. So the limit as x goes to 1 from the left is equal to, from the left is equal to 2. 1 from the left is equal to 2. So 1 from the left is equal to 2. Okay, no problem. So let me make it like this so that I know that it comes from the left. And then from the right, and I guess this is a typo, right? Because if the limit exists, then it's unique. So I'm guessing this is from the right. Okay, so then the limit as x goes to, 1 from the right is equal to 3. So if I'm approaching 1 from the right, it has to take me to 3. And then obviously I'm going to leave it open. I'm going to leave it open because otherwise it's not a function, okay? Look at that beauty. And now I connect the dots. So let me go back to the black color so I can connect the dots. So for numbers less than 0, I have no condition, so who cares? Even a straight line works, whatever. You can do whatever. Wow, I was something like this. Yeah, it's ugly. Something like this. Boom, okay? And then connect this 2. And then this 2. Something like that. Okay. Something like that. And then something like that. Look at that beauty. It was one ugly graph. But you get it, right? As long as you satisfy the conditions, it's fine, okay? It's fine. And it is also a function, so it has to satisfy the vertical line test. That's why you're not allowed to have 2 closed dots, okay? You can have 2 open ones, or 1 closed and 1 open. You cannot have 2 closed dots. Okay, so let's make sure that this graph satisfies the conditions, okay? So let's see. The limit as x approaches 2 from the right, it's negative infinity. So 2 from the right, negative infinity, check. The limit as x approaches 2 from the left is infinity. So from the left, infinity, check. F of 2 is equal to 1, beautiful. The limit as x approaches 0 from the right, 0 from the right is negative 1, beautiful. The limit as x approaches 1 from the left, 1 from the left is equal to 2, done. So I guess I had to, hold on, this is very satisfying. Boop. And then the limit as x approaches 1 from the right is equal to 3. It's equal to 3, boom. Okay, that's it. Okay, let's do one more. Okay? So now I'm going to sketch the graph of a function satisfying those 5 conditions, and then again, we're going to go one by one, okay? So let's see. The limit as x approaches 1, no, the limit as x approaches negative 1, it's equal to negative 3. Notice that this didn't have the one-sided thing. It doesn't have here, it doesn't have a plus or minus, so that tells me that when I come from the left and the right, it has to take me to the same value, negative 3. However, f of negative 1 is undefined. So I'm going to have an open circle, okay? I'm going to have an open circle at negative 1, negative 3. Does that make sense? One more time. Negative 1, what is it? Negative 1, negative 3 is down here, okay? So the limit as x approaches negative 1, it's equal to negative 3. So if I come from the left or from the right, it has to take me to negative 3. But the function is undefined. That's why I'm leaving that open circle. I hope that's clear, okay? Perfect. Now, what else do we have? The limit as x approaches 1 does not exist. So the fact that the limit does not exist tells me that I have to have an open, like I have to have like 2 separate limits. It has to get to one number from the left and a different number from the right, okay? So here we go. 1 does not exist, so who cares? Here we go. 1 closed here and 1 open here. How about that? Okay? Doesn't really matter. So I'm done with this one. Okay? Now the limit as x approaches 3 from the left, it's equal to infinity. We go back to having a vertical asymptote. Okay? Whenever we have positive or negative infinity, that's a vertical asymptote. So I'm going to draw it here. And I'm trying to get to 3 from the left. 3 from the left, and it blows up and goes to infinity. So here we go. Try to get there, but you go to infinity. So that takes care of this one. And then the last one is, as x approaches 3 from the right, it has to be equal to 3. Okay? No problem. No problem. I'm going to make it happen. So 3, I get 3. So it's right here, okay? Right here. And now connect the dots. Go back to black just so you see what I did. So then who cares what happens before -1? Okay. -1, so you can do something like that. And then something like this, okay? And then something like that. And then something like this. Even a line works. Who cares? And then again, you have to go back and make sure that your function, your graph, satisfies those conditions. So let's see. Okay, here we go. Limit as x goes to -1. Here's -1. I get on the graph and it takes me to -3. Check. But f of -1 is undefined. Check. The limit as x goes to 1 does not exist. So from the left, it takes me to 1. From the right, it takes me to 2. Check. The limit as x goes to 3 from the left takes me to infinity. Yes, it does. And then the limit as x goes to 3 from the right takes me to 3. Yes, it does. Okay? Perfect. That's all I have. I hope it makes sense. And on my next video, I'll go over how to compute limits algebraically. Okay? So see you next time.